Right, welcome back to our series of videos about I/O in Java. This is our binary I/O video. And so we need a little bit of background information here. When you do text I/O, Java actually does a lot of work for you. For example, suppose you're going to write the integer 42 and you're going to use pw.print. So we're using a print writer here in order to print this. So 42 is actually an int. It is, of course, therefore a 4-byte int, and internally it is stored as 0000002a, right? 2 times 16 is 32 plus a or 10 is 42. That has to get converted into the two ASCII characters that represent 42 as you read it. So the 4 is hexadecimal 34, and the 2, the character 2, is hexadecimal 32. So what gets sent out the output stream is 0x34, hexadecimal 34, followed by hexadecimal 32. Now, because this shows up in a file or because it shows up at the terminal when you read it, it's going to look like 42 to you, the number 42, but of course it's actually two hexadecimal values. Input works in the opposite way. If you tried to read the integer 42 from scan.nextInt, what you type is, or if you're providing a file, what you read from the file is the ASCII character for 4 followed by the ASCII character for 2. That means you are actually reading hexadecimal 34 and hexadecimal 32. But that's not the number 42. The scanner, nextInt in particular, then converts it into this value 0000002a. So a lot of work is taking place, conversion back and forth between characters and just sort of raw bytes. In contrast, binary I/O is way easier, no conversion required. If you want to write the integer 42 and you want to use writeInt, then what you're going to do is you are going to take those 4 bytes, 0000002a, and send those 4 bytes out the output stream. So, and we're going to be using something, this is called a data output stream, and we're going to use writeInt. So this has the effect of simply sending 4 bytes, the same 4 bytes that are used to represent the int internally, sending those out along the output stream. Now, if you open this up, you would be a little bit disappointed, because if you said dos.writeInt 42, what you are sending out are 000000 and 2a. What does that look like? Well, the zeros are nulls, and so you're in terms of the ASCII table, there's an ASCII character actually called null, which is 00. And so you're going to see 3 null characters, which means you're not going to see anything at all because they don't have a physical representation, followed by 2a. And if you look at the ASCII table, you will find that hexadecimal 2a is the code used to represent an asterisk. So you're going to write out 42 and you're going to open it up and think, well, that's weird. Where'd my 4 and my 2 go? Where's my 42? All you see is an asterisk. But if you read it in binary as well, all would be good. So before we sort of plunge into the details of how we use one of these output streams, like a data input stream or a data output stream, let us take a moment here to admire the hierarchy. Now, normally when we write hierarchies, we write the superclass at top. In the interest of making this fit on the page, this is being written from most general to most specific. So we've got an object. Input and output streams are subclasses of object, and all these other streams are outputs as well, or are subclasses as well. So we're going to be looking at data input stream and data output stream. We'll take a quick glance at file input stream and file output stream as well. There's a lot of stuff here, and we're not going to look at object input stream and object output stream directly. We'll be looking at subclasses that can give us the power that we need to write out objects. Pretty amazing stuff. So what can you do with an input stream? Let's make this just a little bigger here for a moment. All right, with an input stream, you can read an array of bytes. You can figure out the length of something or other. I guess that's the number of bytes that you're planning to read. You can do output stream where you send an array of bytes out through the output stream, which is hopefully going to be connected to some file. There's not a lot that you can do here. In fact, there's not even a mention of files here, so this is actually pretty primitive. The file input stream and the file output stream, which are subclasses of these, introduce a file. So now you have a way of sending, getting input from a file or sending output to a file. So these constructors, and again, the file output stream is built on top of the output stream, give you extra power. Is anything missing from this? Do you look at these methods and say, I am content to be able to, now remember, we're talking about inheritance here, right? So the input stream has the ability to read a string of bytes. The output stream and its subclass, file output stream, has the ability to write a string of, or an array of bytes. That doesn't sound like a lot of power, and it's not. What we're missing here is the ability to read and write the types that we are familiar with, the primitives, objects, and so forth. So, but here's an example anyways. This is how file input stream and file output stream might work. So you can see what we're doing here. We first create a file output stream, and we're using one of these try with resources ideas, so we can simply not have to worry about closing output after. So we're going to create a new file output stream. It's going to be called connected to a file called demo.dat. And because this is a file output stream, again, if we look at what's available to us as an output stream, we have the ability to write an int. It actually just writes it out as a byte anyway. And so there's not a whole lot going on here, but we're going to write out a series of 10 bytes, and then if anything goes wrong, we'll catch a message. And then we're going to use input. We're going to read those 10 values, and then we're going to simply echo them to the console. So let's just see this in action. All right, so here is our project in Visual Studio Code, and if we hit F5, ooh, it complains, temp.dat, no such file or directory. We really ought to, let's see. Well, you know what? It did something. Here it wrote out to demo.dat, and here it tried to read in from temp.dat. I think I did some editing in one place, but not in another. Hang on a minute here while I fix this in real time so that what you see when you get these notes will be correct. There we go. And I'm just going to get this playing again. All right, one more time. Let's go ahead and do this. Many fewer errors than previously. All right, one fewer error than previously. So let's take a look at demo.dat. Oh, that's not very useful at all, is it? So if we open up demo.dat, we just zoom in here as much as we can so we can see what's going on here. You can see that it's very strange indeed. It's got some red boxes with what appears to be SOH, STX, ETX, EOT, ENQ, ACK, BEL, and BS, which stands for backspace, not what you're thinking. So what's going on here? To truly understand this, you have to take a look at the ASCII table, but these are characters that are at the very beginning of the ASCII table, and that's why we are seeing them appear here. So we're writing out a single byte, and so we're not really going to see what we had hoped for. Let's just go ahead and find an ASCII table. Might be educational to do so. All right, so sorry about all the ads here. They're actually pretty revolting. Let's see if I can hide some of them. Nope, can't hide that one. Let's see if I've got something. Let me just see if I can go into read mode. There we go. Oh, great, now I've lost the actual table. Perhaps I should have researched this a little bit ahead of time. I hate ads. Well, we'll just have to live with it. You can see here that we've got our ASCII table, and we've got 0 is null, so that doesn't show up at all. SOH is start of heading, that's got a value of 1. STX is start of text, that's got a value of 2, and so forth. So the bytes that we wrote out actually ended up in the file, and when we open them up in Visual Studio Code, it's actually smart enough to show them to us. Okay, let's get rid of that obnoxious ASCII table and let us never look at that again. Once we've written them out, we can read them back in, and then you can see here that we're taking the value and then we're going to go ahead and print it out. So remember now, when we are doing print down here, we are in fact doing a conversion, right? We are converting from actually what turns out to be a byte, that it's getting upgraded to be an int, but it's converting it into ASCII text so we can see it, which is why we saw the numbers 1 through 10 appearing here. Okay, so that's a file input stream and a file output stream. They allow you to write individual bytes back and forth. File output stream sends bytes to a file. File input stream reads bytes from a file. As a general rule, you're not going to read individual bytes. Rather, you are going to read more complex structures. And they only, again, the problem is that these only work with 1 byte at a time. And there are other classes that provide a little bit more power. And the ones that we really care about, the ones that start to really bristle with power here, are data input stream and data output stream. So you can see here that an input stream, then we have what's called a filter input stream, and then a data input stream. We'll skip over this one. This has the ability to read a whole bunch of different types. You want to read a double, you can read a double, it returns a double. You want to read a long, it returns a long. And the same thing happens with data output. Do you want to write a double? Yes, it will write it out 8 bytes. Remember, a double is 8 bytes. You want to write an int, it will write it out as 4 bytes. So data input stream and data output stream give us a tremendous amount of power. These are the classes that we want to use when we are doing binary I/O. All right, so here we have a more sophisticated example. We're using data input stream and data output stream, as well as our print writer. And so what we're doing here is we first of all make a data output stream based on a file output stream. So this gets a little complicated, figuring out what the constructors want, but a data output stream requires a file output stream. And I'm going to have you just look back through the constructors wherever they are specified. And so we've got our file input stream and file output stream. You can see that those take files. No mention, at least for the input stream, you can either specify looks like you can specify a name or a file, and then a data input stream. The constructors are not specified here. Actually, they are specified right here. You can see that it takes an input stream or an output stream, such as a file input stream or a file output stream. I know that sounds a little complicated, but basically, just remember, this is the structure. You want a data output stream, you'll need a file output stream. Once you've got your data output stream, you can send out various primitives to it, close it when you're done, or we also could have put this in a try with resources block to avoid having to manually close it. And we then set these back to different values, so to show that there's no chicanery happening here. And we then go ahead and read from the same file that we just wrote to. And then we print them out using print writer to send to the console. And you will see that we're writing out 4 bytes and 1, maybe 2 bytes. And then we're going to write out 4 bytes and then close it. So if we actually run this, let's just go ahead and do that right here. So make this just a little smaller. All right, so we're doing, let's see, we're going to run DOS demo here. And when I go ahead and do that, we can see it wrote out 4.5, true, and 3210. If we were to open up test.dat, It has no idea what to do with it. It is not displayed because it's either binary or uses an unsupported text encoding. Open anyway. Sure. Let's just use the built-in text editor. Oh, it looks like total gibberish. Because we are writing out values that are not ASCII, right? This is just binary data sent out as binary data. For those of you who have studied IEEE 754, this is the 4 bytes in which a float is stored. And if you worked really hard, you could figure out what those bytes actually are in the file. All right, so that's a data input stream and data output stream. The one thing that you can't do with these, the one thing that's missing, take a look. What's missing? You can write a byte, you can write bytes, you can write a character, you can write a float, a double, an int, a long, a short. You can write out a string as UTF. What can't you write out? What can't you, up here with the data input, what can't you read in? Objects. You can't read objects. Java has a cure for that too. Object input stream and object output stream. They provide the ability to write an entire object in one go. So if an object had 20 different instance variables, you don't have to write out each instance variable. You just write out the entire object. It automatically writes out its instance variables for you. Likewise with object input stream. You read in whatever you want and it constructs an object out of it. There's a rule, there's a requirement that the classes that you want to write must implement the serializable interface. But good news, this interface is as complex as the clonable interface. That's right, it has nothing in it. It's just a marker interface that indicates that, yes, you intentionally want to be able to write this out. So there's this, again, there's the serializable interface. And here's an example. So I am going to take a file output stream and build an object output stream. Instead of a data output stream, an object output stream out of this. I'm going to take values, which is an array, and I can write that out. And then I can write out an array of books. Now again, the book class has to implement serializable. This will work with arrays automatically. The important point is you're writing these things out in order. So if you write out an array of ints followed by an array of books, you must read them in that order, and you have to do typecasting. Java doesn't know what type of objects you were planning to write out, so this simply returns an object array. You have to typecast it to be an int array. All right, so that has been a whirlwind trip through object input stream, object output stream, and a whole bunch of associated classes. I hope you found this video useful, and if you have any questions about it, I will take them in class when I'm back in class.